Hey guys, this is our 5.9 linear combination. Well, there are formulas involved with the linear combination. In fact, we start with something like a cosine x plus b sine x, and our goal is to get to a form like 4 cosine x minus d, where c is equal to the square root of a squared plus b squared, and cosine d is equal to a over c, and sine d is equal to b over c. Let's go ahead and transform the first one. On the first one, I have square root of 3 cosine x plus sine x. I will keep referring to these formulas above here. So keep looking at these. Now, on the first example, I have square root of 3 cosine x plus sine x. On this example, I can tell already what the value of a is. So I will say a is equal to the square root of 3, b is equal to 1, and c will be equal to the square root of, I missed the equal sign here, c is equal to the square root of 3 plus 1, which is equal to 2. Now, note that this expression is in a specific order, where the cosine comes first and the sine is next, with a plus in between. If the cosine comes first and the sine is next, then you can use this formula. If not, rearrange it to the point that it looks exactly like this. So on the first problem again, going back to it, I will say the cosine of angle D is equal to A, which is square root of 3, over C, which is 2. And at the same time, the sine of D is equal to B, which is 1 over 2. Looking at the cosine and the sine, they're both positive, so I know that I'm in the first quadrant. Be in the first quadrant where the opposite is 1 and the hypotenuse is 2. I will have a principal value of pi over 6. Therefore, I can now rewrite it as c cosine x minus d will be c, which is 2, cosine of x minus pi over 6. And this is my solution. Let's do the same thing for the second problem. This time we're transforming to a single cosine again. Here it's not in order. The first thing I need to do is rewrite this one as negative cosine of 5x plus the sine of 5x. It is very important for you to have it in order. Once you reach this level, you will be able to tell that a is equal to negative 1, b is equal to 1, and c is therefore equal to the square root of 2. Well, the cosine of d is equal to a over c, which is negative 1 over square root of 2. The sine of d is equal to b over c, which is 1 over square root of 2. Looking at these two, the sine is positive, the cosine is negative. So it's located in the second quadrant. And it's a triangle here where I have the adjacent negative 1, square root of 2, 1. And here the principal value will be not pi over 4, but 3 pi over 4. Now that I have the value of d, I will say c cosine of 5x. Note that I'm using the same argument here. The argument was 5x, and I'm using 5x. c cosine 5x minus 3 pi over 4. I should say minus d. And of course, my d, instead of c, by the way, I can replace it by the correct value. And my c here is square root of 2, cosine of 5x minus 3 pi over 4. Well, let's go ahead and do the last one. The last one requires us to solve. And when it says solve, we need to find the final answer. Two things are important. You need to know that your answers are in this interval. Once again, it's not in a correct order. All I will do is work on this part first. I will try to condense this part. Now, I work all of this in green. So I will rearrange it as cosine 2x minus square root of 3 sine 2x. So from here, I can identify that a is equal to 1, b is equal to negative square root of 3, and c is equal to the square root of 3 plus 1, which is, let me write it, square root of 1 plus 3, which is 2. Let's go ahead with the cosine of d is equal to 1 over 2, while the sine of d is equal to negative square root of 3 over 2. From here, I can tell that my triangle is in the fourth quadrant based on this negative, where this is negative square root of 3, 2, and 1. Therefore, my principal value here, which is the value of d, is equal to negative pi over 3. Once I get that negative pi over 3 is my principal value, I will go back here now and start solving as c, which is, note that I'm still writing my c times the cosine of, using this formula again, c cosine of x minus d, and that's what I'm going to use here. I'm just not going to rewrite c cosine. So let's go ahead and write our correct values. C here is 2 cosine of x minus pi over 3. All right, I have x minus negative 5 pi over 3. Note that d was negative, so I have a double negative here, and the double negative will end up being 2 cosine of x plus pi over 3. And this is now equal to this portion that I will write as the square root of 3 here. So it's like I'm starting a new problem. So if I'm done with this, I can stop here and now solve this new part. And I will continue it right here. So I will divide everything by 2 to get cosine of x plus pi over 3 is equal to square root of 3 over 2. Once again, we use our card and it's positive. So since it's positive, I know it's in the first quadrant, and the principal value will be pi over 6. You can build it yourself, knowing that the adjacent is square root of 3, 1, 2. So the principal value is pi over 6. So here I will say, because it's cosine, I will say x plus pi over 3 is equal to pi over 6 plus 2 pi n. Or I will write the second one in a different color, and I will say here x plus pi over 3 is equal to negative pi over 6 plus 2 pi n. From this point, let's go back and work on the blue part. I will say x is equal to, if I subtract pi over 3 from pi over 6, I will have pi over 6 minus 2 pi over 6, which is negative pi over 6 plus, oh, I put x here, it's supposed to be 2. So fix this mistake, it's 2x here, because we started with an argument of 2x. So I was supposed to have 2x everywhere here. Sorry about that. So I have 2x is equal to negative pi over 6 plus 2 pi n. Or the purple one, I will have instead 2x is equal to, that will be negative pi over 6 minus 2 pi over 6, or minus pi over 3. That will be negative 3 pi over 6 plus 2 pi n. All right. At this point, I will divide everything by 2. And if I divide everything by 2, on one side, I will have x is equal to negative pi over 12 plus pi n. Or on the other side, after simplifying, by the way, this is negative pi over 2, I will get x is equal to negative pi over 4 plus pi n. Note that this is just a general solution. Our goal is to find all solutions between 0 and 2 pi. So negative pi over 2 is not a good answer. Negative pi over 4 is not a good answer. So the first good answer is in case I plug in 1 here. So if I plug in 1 here, I have 12 pi over 12 minus pi over 12 will give me 11 pi over 12. The second one is in case I plug in 1 here, I will have 4 pi over 4 minus pi over 4. That will give me 3 pi over 4. Well, what if I plug in 2 here? I will have 2 pi or 24 pi over 12 minus pi over 12 will give me 23 pi over 12. Now let's plug in 2 in this one. If you plug in 2 here, you will have 8 pi over 4 minus pi over 4. That will give you 7 pi over 4. And I believe this is it.